All right, let's go ahead and talk about concentration, which is also known as molarity. So that's what we're going to talk about. And so the concentration of a solution is a measure of the amount of solute, which again, solute is the thing that is being dissolved in a given amount of solvent. And just a reminder, solvent is doing the dissolving. So it's the thing that's doing the dissolving. And so again, it's how much solute is inside of a certain amount of solvent. So I talk about chocolate milk whenever I'm talking about this. And so if we have some milk, we can add 2 scoops of chocolate powder to the milk and it'll have its certain concentration. But what if we added 5 scoops to the milk? Well, adding 5 scoops makes a more concentrated solution. Adding 2 scoops is a less concentrated solution. And so concentration is just a measure of how concentrated something is. Now, a dilute solution, okay, something that's dilute, is considered to have a relatively small amount of solute in a certain amount of solvent. So I give the example of 2 scoops of chocolate versus 5 scoops of chocolate inside of milk. And the 2 scoops is going to be more dilute than the 5 scoops. Then we have a concentrated solution, and that is considered to have a relatively large amount of solute in the solvent. Now, one way in which we calculate this is in terms of moles. Now, we can talk about grams being dissolved and we can talk about scoops of chocolate being dissolved, but for chemistry, we usually talk about how many moles there are inside of a solution, and that is known as the molarity. The molarity is the number of moles of solute in 1 liter of solvent. And again, often the solvent is water. Water is the universal solvent. Now you can have some other solvents, but like acetone or something like that, which acetone is nail polish remover. But this is, we usually talk about water. Now, there is an equation for molarity. Molarity is going to be equal to moles of solute divided by liters. And that's how you actually calculate molarity. Now, this is a capital M, just to point out. But yeah, the other thing too is we often express molarity with brackets. So if I have a certain concentration of sodium chloride, you would put it inside of brackets, and we'll look at examples of this in a little bit. All right, let's go ahead and go to some practice problems. So these problems are really easy. Again, molarity is equal to moles divided by liters. And so if you have 4 liters of a solution and it contains 116.9 grams, the question is, what is the molarity? So again, molarity is what we're looking for, and there's 2 things we need. We need moles and we need liters. Well, we have the liters right here, but we don't have the moles. However, we can take our 116.9 grams of sodium chloride and we can convert it to moles. Go from grams to moles. And we just use the molar mass, which is going to be 58.44. Again, we get that from the periodic table. And then you just type this in your calculator to get the moles. And this ends up being exactly 2.000, because of sig figs, moles. And to find the molarity, you just need to take the moles divided by the liters, which is 4 liters in this situation. And you end up with 0.500 molar solution of NaCl. And this is our answer here. And so what that means is, if it's a 0.5 molar solution, that means for every liter you have half a mole. You have 0.5 moles for every liter. In this situation we have 4 liters, so that means that of those 4 liters, every one of those liters has half a mole. All right, let's go ahead and go to the next one. You have 8.8 liters of a 0.5 molar solution. The question is, how many moles do you have? Well, again, molarity is equal to moles over liters. All you do is you plug it in, so we have 0.5 moles, and that's going to be equal to the moles divided by the liters, which is 0.8. And all you do is simple algebra. And you end up with the moles is equal to 0.4. And this is 0.4 with sig figs. That actually is with sig figs. Moles of HCl. That's how many moles of HCl you have. And so that's it. This is really basic stuff. You should be very familiar with this at this point because we've been dealing with moles for the whole year. And so really just understanding this equation here is all you need. So that's all there is when it comes to concentration. This is going to be, and the next thing I want to talk about too is I want you to make the connection with this and stoichiometry. So how might you apply this to stoichiometry? Because that's where we're going to be going in a couple class periods. And that's it. That's all I've got for you. Have a great day. Take care.